This is a diamond. Now, diamonds have a problem. No matter how hard they try, these things are completely and utterly useless for conducting electricity. And it all comes down to the structure and bonding within the stuff that they're made from. Every single diamond is made only from carbon and nothing else. Diamond's a beautiful example of a giant covalent structure. Whenever you hear giant, it's sort of the opposite of a simple molecular structure. It consists of a potentially infinite number of atoms in this repeating pattern. And diamonds is a giant covalent structure because all of these atoms are bonded to each other with covalent bonds. Now, did you know that if I was to tweak the bonding just a tiny bit, I wouldn't have a diamond, but I would have graphite, the stuff in pencils? The only difference between a diamond and graphite in pencils is that in diamond, every carbon atom bonds to 4 other carbon atoms, whereas in graphite, every carbon atom only bonds to 3 other carbon atoms. Both are still only made from carbon, but they have wildly different physical properties. One key difference we already mentioned is that because diamond has no free electrons, since all 4 bonds are taken up, there's no free electrons to conduct electricity, so diamond doesn't conduct. Graphite, on the other hand, will form these sheets with 1 electron free that is unbonded. That means they're able to flow through and conduct electricity. Now, these sheets that you can see here, those individual sheets are called graphene. Together, this is graphite. Because we form these sheets, they're able to slide over each other because there is no covalent bond joining one sheet to the next. These lines on the diagram represent weak intermolecular forces, weak forces between the separate molecules, which are these separate sheets. Because we form those slippery sheets, it makes graphite a really useful substance to use as a pencil because one little sheet will slip off and stay on your page when you're writing with your pencil. Due to its slippery nature, we can also use graphite as a lubricant, but make sure you don't tell P. Diddy that. Back over to diamond. Now, since every carbon atom covalently bonds to other carbon atoms, covalent bonds are really strong, and that makes this diamond substance really, really hard. The hardest substance that we actually know of. And hard things make really good cutting tools. So we use diamond. You see diamond-edged blades and diamond-edged drill bits. The last thing to note about these awesome things, diamond and graphite, since they have loads of covalent bonds, those really strong bonds, they're very hard to overcome. It would take so much energy to overcome those really strong covalent bonds if you wanted to melt or boil diamond or graphite. Therefore, they have a really high melting and boiling point too. That is a proper common 6-mark question in GCSE chemistry, and just about everything you needed to know there if you're asked to compare diamond and graphite. Pop me a follow if that was helpful, and let me know in the comments if there's any other topics we could do a quick story time like this for.